Hello, welcome to this video. This is integrating the natural logarithm function, and we are in lesson 7.6, the last lesson of this unit. Are you excited? I'm going to go ahead and split this video into, or this lesson into two separate videos. This video is specifically going to focus on one aspect, and I'll talk about that in a second. The second video will focus on another aspect of integrating natural logarithms, okay? So, we're going to go ahead and start off with your knowledge of differentiating the natural log of x. So remember, the derivative of the natural log of x, or the absolute value of x, is 1 over x. Okay, so thus, if we integrate, okay, the integral of 1 over x dx is going to be the natural log of the absolute value of x plus c. And similarly, this video will also incorporate reverse chain rule. If we are taking the derivative of the natural log of the absolute value of u, where u is a function of x, we have to incorporate the derivative of u, right? So u prime over u. So similarly, we're going to see problems where we have reverse chain rule, where we have to identify, okay, what's our hook? What's the derivative of the function that we want to integrate, okay? So maybe you're asking yourself, okay, well, where in here, so here's our log rules, where in here is, where in here is our natural log of x? Like, what's the integral of the natural log of x? We'll talk about that in the second video, okay? So I just want you to focus on here. We're taking that idea, the derivative of a natural log of x is 1 over x. So we're going to be integrating 1 over x in this video, okay? And note here, although it is true that the derivative of 1 over x, or sorry, the derivative of natural log of x is 1 over x, and the derivative of the natural log of absolute value of x is 1 over x. When we integrate 1 over x, we have to prevent domain issues, okay? So we have to account for all domain values. So we always, when we integrate, it is equal to the natural log of x, okay? So make sure that you're aware of that. So we always have to include those absolute value brackets. Okay, let's go ahead and integrate. So example 1, we're asked to integrate the absolute value of -3 over x dx. Okay, so what I want you to see in these problems is that we have an x to the power of 1 in the denominator, x to the power of 1 in the denominator, okay? And it helps sometimes too if you just kind of isolate that this is equal to the -3 integral of 1 over x dx. Okay, so what is the integral of 1 over x dx? Well, it's the natural log of the absolute value of x. So I have -3 times the natural log of the absolute value of x plus c. Okay, and there is our answer. That's it. I want to point out, and I'm going to put this in red, I'm going to say over here off to the side, do not do. Maybe you're asking yourself, hey, why am I not rewriting this as -3x to the power of -1 dx? Well, if you did, okay, and if you are using the power rule, you would have -3. Okay, what do we do with the power? Well, I'm going to add 1 to it. That's x to the 0. Okay, and then I have to divide by that power, and we're dividing by 0. The world just blew up. Okay, you cannot divide by 0. So, you cannot use this method, right? That's why I had you right here. Do not do. Maybe you want to leave that just as an important reminder to yourself. Okay, example 2. Example 2 is where we're going to see the reverse chain rule and kind of the other formula for integrating 1 over x. Okay, so what we want to go ahead and do here is notice that I have a function in the denominator, okay, p squared plus 1. And if I went ahead, and again, we're going to be utilizing this formula here, so u prime over u, okay, I need to go ahead and identify, okay, like what's my function? And I'm going to say u is equal to the denominator, so p squared plus 1. Don't freak out. We're not doing u substitution. We'll save that for the next video. We'll get there. Okay. U is equal to p squared plus 1. So then I have to say, okay, like what is u prime? Like what's the hook? Like if I was to integrate this, like, and then differentiate, right? I have to have the hook or the chain rule. So the derivative of this would be 2p. Okay, so notice I do have the p counted for, but I'm missing what? I'm missing a 2. So I'm going to go ahead, I'm going to rewrite this. I'm going to rewrite this as 1 over p squared plus 1 times, okay, and I'll put the p over here. This sounds so weird. I'm putting the p over here. Okay, and I'm missing the 2, so I have to incorporate a 2, and when I add something, I have to go ahead and balance it, 1/2. Okay, so there we go. There is my hook right here, right? The 2p over dp. Okay, or 2p times dp. dp. All right, so I have 1/2 times, okay, and I'm going to go ahead and integrate this. So 1 over a function is the natural log of the absolute value of that. So p squared plus 1 plus c. And there you have it. That's it. Not too bad, right? Not too bad. Okay, number 3. Similar idea here. I have a function in the denominator, okay, of a higher power, and generally that is going to be the function that you're going to be looking to go ahead and integrate, right? The function in the denominator, 1 over x, that's what we're looking at. So in the denominator, I have t cubed minus t squared. So then the hook with this function, its derivative, right, if it's going to go away, okay, is going to be 3t squared minus 2t, right? I just took the derivative of it. And what I want you to see is this numerator up here. Okay, if I rewrite this function, this is the integral of 3. If I just factor out a 3, do you see the t squared in the t? So I factor out a 3, and on the inside we're left with 3t squared. Oh, there it is, right? Okay, there's our hook that we're looking for. So t cubed minus t squared dt. Okay, so here's what you do. You math magicians, you're just going to factor that 3 out. I'm going to pull the 3 out. Okay, and I'm going to write my function 1 over t cubed minus t squared times, and I'll write my hook over here. So I have 3t squared minus 2t dt. All right, there is the hook, right? And what happens to it? It goes away. We say, bye, Felicia. Okay, and we get 3 times, okay, 1 over a function of x is the natural log of that function. So I have 3 times the natural log of the absolute value. Don't forget your absolute value. Plus c. And there you have it. Okay, not bad, not bad. All right, now I'm going to give you a case where we're going to have to do some extra stuff, and it requires a little bit of side work and stuff that you've already learned. When integrating a fraction where the degree of the numerator, so the degree of the numerator is greater than or equal to the degree of the denominator, okay, you will have to use long division, okay, or creative thinking, long division, to split the fraction, okay? And I'll go over that, but I want to highlight what we're talking about here. So notice the degree of the numerator, x squared, is greater than or equal to the degree of the denominator. Now, if I was going to go ahead and integrate using natural logarithms, right, thinking about the integral of 1 over x is the natural log, my hook doesn't account for everything in the numerator. So what we're going to have to do is rewrite this function. And you have done this before. You did this when in Accelerated Math 3 when we were rewriting rational expressions. We had to utilize long division. So over here off to the side, I'll write long division. And I know you guys love long division. It's the greatest long division. And it's not so bad. So I write the divisor out here, x squared plus 2 divided by, or divided into, or dividend, x squared minus 4x plus 2. Okay, and I'm going to go ahead and divide. What you need to be careful of, notice that you do not have an x term here. So if you want to rewrite this, you can go ahead and rewrite this as x squared plus 0 plus 2. You need a placeholder, and you can put a 0x. I'm not a fan of putting in the variable there in the power, just because some people think that there's an actual term there. There's nothing there, so I put a 0 just to know that there's a placeholder, and I'll show you why I do that in a second. But x squared divided into x squared, that is 1. I'll put this in red. I'll show you why I'm doing that in a second. So 1. Okay, 1 times x squared is x squared. 1 times 0, 0, and 1 times 2 is positive 2. So I need to go ahead and subtract, change my signs. So this becomes negative, this becomes negative, this becomes negative. These terms cancel. Here I have negative 4x, take away 0. So negative 4x will be the remainder, and the 2's cancel. Okay, so here is my quotient. This function, I'm going to go ahead and rewrite this, will be the integral of 1 plus negative 4x over my term. So x squared plus 2 dx. And actually, I had that 1 for a reason. I want you to make sure that your quotient, right, you put the 1 by itself, and this is your remainder, the negative 4x here. Okay, so just some things to watch out for. Okay, so we're going to go ahead and integrate this. And what I want to do is I'm going to split this, because this is much easier, right? The integral of 1 is just x. We know that that's just x, okay? Plus the integral of negative 4x over x squared plus 2 dx. Okay, so I want to go ahead and integrate this. Again, my denominator, notice that if I write this as a function, so I'll say u is x squared plus 2, and then the derivative of this, so u prime would be 2x. Okay, well, notice I have the 2 accounted for, right? And I have an x. So I'll go ahead, and what I need to do is I need to factor out a negative 2. So I'm going to factor out a negative 2 plus negative 2 times the integral of 1 over x squared plus 2 times 2x dx. Okay, and there's our hook. That's going to go away. So this becomes equal to x minus 2 times, and again, this is the natural log of the absolute value of x squared plus 2 plus c. Okay, and there is your answer. And if you want to rewrite this, you can. X minus 2 times the natural log of x squared plus 2 plus c. And there is your answer. All right, I'm going to go ahead. I'm going to end the video here, and I'll talk about the next set of examples in integrating. How do we integrate the natural log of x in the next video? Catch you next time. Peace.